Um, mm, 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 Okay, like your life after 35 seconds. No, time flying. Time waits for no one. We're going to solve a zip with, as in chapter 3, using unfold. And this is early I was trying to remember this function. So I look for the chapter 3. The first appearance of this word is zipWith. So then I went to so there is no exercise called zipWith. If you look for oh my God, three, oh my God, should be over here, should be over here. Okay, generalize the function you just wrote, so it's not specific to integers or addition. There's not zipWith. Write a function that accepts the list. Then I look for my answer, which looks then yeah. Then I was curious and I searched for my answer prior to this video. And here it is. We called our solution combined with function. And we did it with in a tail recursive flavor. And we decided to throw an error if the list the same size. And we reverse, at the end, we reverse the result. That's look at this 3.22 and 3.23. Now, the answer in the book, they have two solutions. In here, they are using a structural recursion, and in here, they're using tail recursion. Tail recursion. Notice, but they are also doing a reverse at the end. So I don't know how it will work for. They are not throwing any error. So this seems a little bit, again, unfold. Feels like counterintuitive because you are producing a list, generating a list, and here you are like just simplifying problem. So let's get started. Minute 4, and we have our URL. Since the exercise 5.13 send us to this chapter 3, we will have to take a look at this. We're receiving a list A. Also, I want you to see that the type variables, they have A, B, and C. And in here, we just have A, B, and returning a B. So we managed to get away with these only two type variables. But perhaps it's a good idea to use three type variables. To be honest, I don't know if currently it does what the exercise proposes. We made two generalizations here. First, we figure out plus variant into a function that's faster to zipWith as a parameter, and second, we allow the types of each list to be different. Hence, we need three type parameters. Two for the input list and one for the result list. To make this stack safe, we can pass the cumulative value into our goal. So, first recursion of the so since we can compute, so here this they are allowing three types, different types, and in our version, perhaps in this they can, I don't know, they can, yes, they can. For example, this could be a list of int, a list of string. This could be a tuple, and in our case, it should be one of these two. Well, let's get started because it's getting late. Okay, so list C is the result. Maybe match is nil. They give you nil. Yeah, this unfold is kind of. I haven't solved too many exercises. We already have A. zipWith using fault. We need migration list like B. We already have uh, so this guy is sending the function inside the parentheses, and we did it inside the parentheses too. I'm tempted to do it outside. Well, let's go with the flow. Function F, A, B, C, and we will have a list of type C at the end. So let's use the same name. A. This can be N, so let's use that. For happening. Sometimes this, okay, we need a state and we need a function. our state will be is that. Why is that? Because well, we need to like use the place list. We need to traverse the elements. And now we have our case empty. Do we have one with two? Yes. Yes. Empty. None. Why none? Because none will give you the empty list to cons at the end. Case. None two. Now we are talking. And yeah, cons. Here, instead of using the big names head, we will use H. H1, T1. Yeah, we need cons. You might be tempted uh, to say, well, this guy is actually adapting the answer from the book, and you might be right. But remember, the book says that uh, complete the solve the exercise as in chapter 3, and we already have our version over here. We can use our version, and it will be the same. I will be, like retyping the thing, adapting. Sorry. The main thing here is the reasoning about unfold. I wonder if an AI system can we will do the exercise. At the end, if we get it right, if we get this thing right, we will put this thing in an AI system, some prompting to, for the in order for the AI system to search within the data in which it was trained. Okay, I'm talking too much, wasting my time. How many minutes? 13 minutes. Yeah, some F1, H2, and the next state will be T1 and T2. Please compile. Okay. We copy paste this. 1, 2, 3, 4. 1, 2, 3, 4. It has the same number of elements. So in here we'll remove my other lazy list. We will have 5, 6, 7. So we're going to use my lazy list, that lazy list, and then my lazy list, my other lazy list. My this Scasti guys should be like fixing this zipWith using unfold. We need that lazy list, and we need let's multiply them. Like these are big numbers: 20, 200, 800, 2000, and 2100 and 1500. 200, 800, 2100, and oh my god, 20, 200, 800, 2100, and 1500. Now this has less, these are like 3 elements instead of 4, so let's use it. My other layer, oh my god. Everything using 12. My lazy list. And let's solve this thing. Should be the element. Oh boy. Yeah, 7, 10, and 14. 7, 10, and 14, and we left out the 3. So we got we adapted our solution, our previous solution to using unfold. It doesn't matter if we didn't have the code. We already solved this exercise, so we are like capable of doing this thing again. But why? We already did the exercise. Well, it's good to be practicing. What's on, what's off. Well, this is it. This is it. 100%. So we improved the thing. Very happy with this. As always, I was hesitant. But like we need to get rid of our nervous and take a jump into the void. we know two or how did they say one or two things about this, but it's always risky to show yourself like this. You can fail like big time. Perhaps some people won't understand that. You're trying to show like the effort behind. There's no such a thing as geniuses in my point of view. Some people are like that because they start from in their childhood, but and that's great. But other people, strugglers, shouldn't dismay. There is hope. That's my message. I want. That's the message I'm trying to deliver. Thank you very much. Have a week. Happy week ahead, and happy rest of the Sunday. Bye. Oh yeah. Let me. I was about to leave, but like. Um, hmm. If we continue like this, we won't reach. We're doing a little exercise every day, which is good, but perhaps I will tackle the rest of the chapter because there is no new concepts. I took a look to the exercise. I didn't read the exercises. I just skimmed the rest of the chapter, and I saw one that says art. Oh my God. uh, yeah, but I will try to do all to solve to spend like 6 hours with those. Like I did it like I did with Blender some weeks ago. And let's see how it goes. These are the answers. We missed like this the iter data type, the flat map, the annotation. No, this is we get this thing right. There's one with the all right using an annotation. I didn't know what you get to annotate. Functions already in the Scala library. Yeah, but with itself, we provided the iter data type complete. So I'm happy with that. zipWith. In chapter 3, look at this, here it is. Okay, thank you very much. Bye.